Now we've already looked at the 4 different tunics and the different components of each tunic. We need to look at how those tunics are controlled. A little more about how the control of your GI tract works. And for that, that's where the enteric nervous system comes into play. Now this is going to be an intrinsic system. What's interesting here is, by being intrinsic, it's all within the GI tract. That's where you get the idea of a gut brain from, because your GI tract can make its own decisions. Sure, the central nervous system, your brain, spinal cord, they're going to help out. They're going to have control mechanisms and factors, but your actual gut itself, the GI tract, can make some decisions on its own. So we have this submucosal nerve plexus. Now the submucosal nerve plexus is controlling glands, but it's also dealing with the smooth muscle of mucosa. So remember, there is that muscularis mucosae. That's being controlled by this submucosal nerve plexus. The other muscle that's in the muscularis externa is not controlled by this. The myenteric nerve plexus controls that layering. So the myenteric nerve plexus controls more of the GI tract motility. That means it's controlling both the circular and longitudinal layers that are found in the muscularis externa. So this one, 2 different layers. With the submucosal nerve plexus, we have the myenteric nerve plexus. Each has its own jobs, but they're both answering and part of this intrinsic nerve system, this enteric nerve system. Now sure, it's linked to the central nervous system, because the central nervous system is going to have over-controlling arching themes here. The idea is it kind of controls the broader swatches, controls the whole system, makes sure everything is working properly. Now it's being here via the afferent visceral fibers. So again, we're looking at the fibers that are coming from the actual and going to the actual central nervous system. In this case, we're going to start with the afferent fibers. So looking at the ANS, autonomic nervous system. Now the autonomic nervous system is both sympathetic and parasympathetic. So in this case though, we're focusing on the sympathetic is going to be dealing with impulses that are inhibiting secretion and motility. Well, think about it for a second. Sympathetic, more fight and flight, just get your muscles ready, getting your respiratory system ready, heart and cardio's going. Is GI tract really part of that fight or flight? No. That's why sympathetic is going to inhibit motility, inhibit secretions. Because in those cases, you don't need it under sympathetic control. But under parasympathetic control, now notice the impulses are all for stimulation. You're going to cause secretion. You're going to cause motility to occur, the movement throughout the system. So motility basically is you're moving those chewed up food particles, those bolus, down the passages. So parasympathetic causes it to keep working. Sympathetic kind of slows it down and stops it. Now we have these 2 terms here, peritoneum and peritoneal cavity. Now the peritoneum and peritoneal cavity. Peritoneum is actually a double layer system. What you're going to have here is basically being the mesentery, the first part of the peritoneum we want to talk about. Mesentery is where you kind of have a whole area of connective tissue that's going from different organs, different parts, different regions, carrying blood vessels, carrying nerves. It's a way for allowing everything to be connected. So when you think about the small intestine, the large intestines, they're all just tubing, but you still have to have them all connected. So that's what the job of the mesentery is, connecting it and allowing for a place for all the blood vessels, all the nerves, all the controlling mechanisms here. Really meant to hold the organs in place. Now I have on there, it also stores fat. True, there will be a little bit of fat storage in the mesentery, but one of the biggest things is keeping things in order, keeping things in location. Now there are some retroperitoneal organs. Retroperitoneal organs are the ones that are behind this whole enteric cavity. So they're not part of the peritoneum. They're lying back or posterior to it. Probably one of the easiest ones to think about are the kidneys, for example. They're retroperitoneal. They're behind the peritoneum. And then you have the intraperitoneal organs. These are all the ones that are inside of the peritoneum. They're surrounded by this double membrane system, the visceral and parietal peritoneum. Looking at the peritoneum, the colored lines you see here, that kind of almost a off blue coloration, you have a double membrane system right here. Notice how the entire outside is two lines side by side. That's the visceral and parietal peritoneum. The outside line, which is this one out here, that's the parietal peritoneum. It lines the outside of the cavity. While the visceral peritoneum, that's this one inside, the visceral peritoneum is like saran wrap covering the organ. So each one of these organs, from the liver to the stomach to the small intestines to the spleen, they're all covered by this visceral peritoneum. Parietal peritoneum simply lines the entire outside covering here. It lines the cavity. So a double membrane system. Question is, why? Well, if you can think all the way back to that very first unit in AP1, this visceral parietal double membrane is meant to reduce friction. Think, if you bend, you move, you twist, all those organs are also shifting and moving just a little bit. Not even counting peristalsis or segmentation, that's also movement inside there. You're trying to reduce the friction to almost zero if possible because of this double membrane system. All right, 6 different digestive processes. Now, your entire digestive tract, and for that matter, the entire digestive system, is going to have 6 main processes that are happening. The first is probably the simplest, ingestion. Simply eat the food, you ingest the food. Now, obviously, when you ingest it, depending on what it is, you may have to chew it. But that's ingestion. Propulsion. Propulsion is movement of those particles through the system. Doesn't matter if it's liquid or solid, it's the movement. Things like peristalsis, segmentation, are moving things through the system. And that occurs right from mouth all the way through anus. Chemical digestion. Now, chemical digestion are using enzymes to break down the macromolecules. In your mouth, you're starting with some chemical digestion, because you're going to have some enzymes that start to break down starches in your saliva. You'll continue that chemical digestion in your stomach, your small intestines, even into the large intestines a little bit, but mostly it's done by the small intestines. You then have mechanical digestion. Mechanical digestion, if you notice, is all these circles that are found throughout, even a little bit up here in the mouth. That's because mechanical digestion is any physical grinding the food. Your teeth do that. Your stomach is churning. Your small intestines are pushing. All these are going to be your mechanical digestion. And then you have absorption. If you notice, the absorption has these 4 arrows. That's because absorption is being pulled out of the small intestines. You're pulling, absorbing into the actual bloodstream. You're absorbing into lymphatic tissue. You're absorbing all those products that you ate, things that were your carbohydrates, your lipids, your proteins, your nucleic acids, your water, your vitamins, your minerals. They're all being absorbed out of the GI tract and into your system, either being blood in the cardiovascular system or into lymphatics in some case, because a lot of the fats or lipids go into the lymphatic system to start with. And then the last at the very end is defecation. Whatever your body cannot use or cannot digest. Because there are things like fiber, for example, you cannot digest, just simply passes on through. It's meant to give bulk and roughage to keep your system functioning properly. So 6 different digestive processes. And all of these processes are regulated not only by the GI tract itself, but regulated by your central nervous system as well. It's regulated through things like mechanoreceptors, chemoreceptors, and osmoreceptors. So that's a lot of receptors. Yeah, there is from mouth all the way through anus a ton of receptors in this system. So they respond to things like stretch. Well, stretch is going to be mechanoreceptors. You have then change in osmolarity and pH. Well, the osmolarity is obviously the osmoreceptors. pH is looking at the change in hydrogen ions. So that's chemoreceptors. You have the presence of different substrates, the building blocks of your macromolecules. That's the chemoreceptors, looking at those. And then the end products of digestion, knowing when you have the broken down parts of your carbohydrates, your monosaccharides, when you have the broken down components of your proteins, your amino acids, so how to absorb those and get those out of your system. So the GI tract is a lot of feedback mechanisms to know what is going on, which enzymes secrete, and how to work. So how do you regulate? Well, here's kind of a visual aspect here. You can either have stimuli from an external source, which we'll start with, or an internal source. That internal source we'll get to in a second. But let's say you see food. Ooh, that food looks good. What's happening then is the central nervous system picks up those receptions, saying, hey, I see food or I smell food. What will happen is it then sends it down into that local environment inside of your GI tract. The effectors are the glands causing secretion of mucus and enzymes. The smooth muscle starts moving. If you ever notice, maybe when you're really hungry and you smell something that really smells good, your stomach kind of churns a bit. That's this external reflex here. But then we also have internal stimuli. Things like the chemoreceptors, the osmoreceptors, the mechanoreceptors. Those then are all going to say the same thing. Hey, get things going. You're using the smooth muscle to get going, the different secretions getting going. So either an internal or an external stimuli could cause these to get working and be functional. So that's why you have this short reflex, which is down here. Now the short reflex is just stimuli inside your GI tract, causing reactions inside the GI tract. While the long reflex is having stimulations inside the GI tract, being sent up to the central nervous system, and then that telling your GI tract what to do. So two different reflexes built in to make sure GI tract is responding the way it should. Just a little bit about how you're regulating the different passages throughout your actual GI tract.